After looking over your homework for the quiz review, I felt like we needed a video explaining the problems and just some stuff to try to help you guys get ready for the quiz, because I felt like if I just sort of give you the quiz tomorrow and not really explain this stuff, that you guys might really struggle, and I don't want that. I mean, I want you guys to understand the material. I want you guys to do well. I don't want you guys to fail. So I'm going to work through the problems relatively quickly, so if you need to kind of pause the video and make sure you understand what's going on, I would do that. For those of you that missed problems, you most definitely need to watch the problems that you missed, but I do need everybody to watch these first two graphing problems, because I am going to be extremely strict about the graphs. Like, not joking, I will take points off for not following the directions the way that I've shown you guys to do them, especially when I'm giving you something that's open book and open notes for a quiz. So, starting with number 6. So this is the chapter review. Number 6, y is equal to 5 to the x, and I'm supposed to be graphing it. We're ignoring the domain and range part. So, what is the very first thing I do? Only a few of you do it, so pay attention. Make a table. XY table, labeled with x and y. Okay, very clear what you're looking at. X's are always -2, -1, 0, 1, 2. Okay, these are the 5 values. If I don't see these 5 values, I'm not even going to look at the problem. It's going to be wrong. Okay, you have to have these 5 values written out here. Now, we got to find the y value. So I'm going to plug this value in for x. So this is going to be 5 to the -2, which is 1 over 25. This is 5 to the -1, which is 1 over 5. This is 5 to the 0, which is just 1. 5 to the 1 is just 5. 5 squared is 25. Now, I have all of these values. Now, what I told you is if this value here is greater than 10, you do not have to graph this point. Okay, and the same goes for this one when we have a decay problem. For a decay problem, this is also true. Okay, now I'm going to graph it. So I come over here, and I only need the top half of the graph. Okay, I don't need the bottom, I just need the top. So, on the x-axis, you label everything. You label everything on your graph. I've gotten a lot of graphs that just look like this with something drawn on them. I have no clue what that means. That's automatically wrong. Okay? If your graph's not labeled, points off for the graph. So, we're at -2, -1, 0, 1, and 2. Now, I'm not actually going to be graphing the point on 2, but I'm still putting all 5 on here. Now, I'm really only going up to 5 because I'm not graphing this point because it's greater than 10. So 1, 2, 3, 4, 5. I'm labeling 5, and I'm labeling at least one other one. Okay, so it's very clear what increments you're working in. You always label the first one, and then you label the one you're going up to. Okay? So, now I can graph the points. At -2, I'm at 1/25, so it's going to be barely above the line. At -1, I'm at 1/5, so it's a little higher up, but still not by much. At 0, it's at 1. At 1, we're at 5. And at 2, we're way up out here, so I'm not even going to draw it. But what we do when we draw this in is we draw it just with a continuing arrow, meaning showing that we're going up. Alright, So that's what you have to do for that problem. So if I don't see a table, if I don't see a labeled graph, it's automatic points off, or I may not even look at the problem. So you need to have a table, and the graph has to be labeled. Okay? All right. So we're going to do the same thing with number 10. So 10 is y is equal to 1/8 raised to the x. So, first thing, make a table. XY table. -2, -1, 0, 1, 2. Alright, so 1/8 raised to the -2 is 64, meaning I'm not going to end up graphing that point. 1/8 raised to the -1 is 8. 1/8 raised to the 0 is 1. 1/8 raised to the 1 is 1/8. 1/8 squared is 164. So in this case, this point I'm not going to graph because it's greater than 10. So come over and make my graph. Still only need the top portion. With these ones, you only ever need the top portion. I saw some people drawing their graphs down here. Okay, exponentials, they're all above the top. Okay, we didn't do anything with any that are flipped over or anything like that. So everything's up here. All right, -2, -1, 0, 1, 2. Well, I have a labeled graph. I'm going up to 8. 1, 2, 3, 4, 5, 6, 7, 8. Labeling 8, labeling 1, and probably 1 somewhere in the middle. All right, now I can plot the points. So, a -2, we're at 64, so we're way up here somewhere, like way off the page somewhere. So we're not graphing that one. At -1, we are at 8. At 0, we are at 1. At 1, we are at 1/8, so we're just a little bit above the line. And at 2, we're at 164, so we're even closer to the line. And now we graph it going down. Okay. So, not perfectly rounded. I'm trying to, there we go. Okay, so it looks like that. Your graph should look identical to this. Every single person in this class's graph should look identical to this one and this one. Okay? Because if this number is greater than 10 or this number is greater than 10, we don't plot that point, but we still leave a space for it. Okay? And you all have the same increments. Everything's in increments of 1 because we're not graphing anything greater than 10. Okay? So on the quiz, if by some chance yours doesn't look like this, points off. Okay? So, now we can jump into the actual logarithm problems. Number 17. Log base 3 of 243. And I am evaluating without a calculator. So you need to show your work on these. A lot of people just gave me answers. Not going to cut it. Okay? So, these problems, set them up. We say they're equal to x because we want to know what they're equal to. So then, we're going from log to exponential. So that means I make an e. 3 to the x is equal to 243. So I want to know 3 raised to what is equal to 243. So I can rewrite 243, okay, as 3 to the 5th, which is equal to 3 to the x, okay? And you may just have to do this with your calculator and just keep multiplying by 3. Okay, if I didn't know that off the top of my head, that came up in Algebra 1 a lot. It's the only reason I know that one off the top of my head. I would just keep multiplying. 3 times 3 times 3 times 3 times 3. Okay, and I would get there. That's why you have a calculator. Okay, I'm letting you use it. Take advantage of it. Okay, so now 3 to the x is equal to 3 to the 5th, meaning x is equal to 5. 5 is the answer. Okay, it's technically not x, well, it is x equals, but the answer is 5. Okay, let's see, 18. We have log base 7 of 1. So we set it up. Equal to x. Okay? Now, this is a property, so you could just immediately say, wait a minute, we don't need to do this. This is just equal to 0. Okay? That's a property. Okay, by the property. But if you didn't know that, you could do 7 to the x is equal to 1 and think 7 raised to what power gives me 1? And that would be 0. Okay? So that's another way, in case you don't remember the property, that you can check it. $19. Alright, we have, let's see, log base 1/6 of 216. So, this one I will admit is a little harder, but not by a lot, especially if we do this method. So, make an E. 1/6 raised to the x is equal to 216. Now, my recommendation, okay, is to flip this and get this on top, okay, or like rewrite it with a negative exponent. So write it as 6 to the negative x. Okay, because that way it's just written in a form that's easier to see. Okay, we wanted to move the 6 up, meaning I just needed to make my exponent negative. Okay, so 6 to the negative x is equal to 216. Well, I need to know 6 raised to what gives me 216. So let's just try our method here. Trying to get it. There we go. 6 times 6 times 6. Oh, that's 216. So I can rewrite this as 6 to the 3rd. So 6 to the negative x is equal to 6 to the 3rd. Same base, so negative x is equal to 3. X is equal to negative 3. All right, and then 20 log base 125 of 1/5. So equal to x. Going to make my E. So 125 raised to the x is equal to 1/5. So I could rewrite this as 5 to the negative 1, okay, on this side. And I want to rewrite this in terms of 5. So I could do the reverse of what I was just doing when I was multiplying. I could do 125 divided by 5. Divided by 5, and that gives it to me in terms of 5. So that means it's the cube root of 125. So I'm going to say that this is 5. Okay. I'm about to say this backwards. Okay, this is the cube root of 5. Or this is the cube root of 125. Hold on. Can't write. Okay, it's 125. Sorry, hold on. Scratch that. Ignore that last little thing here. I'm going to write it over here. This is 5 cubed. There we go. So the x is equal to 5 to the negative 1. There we go. Now I have the same base. So 3x is equal to negative 1. X is equal to negative 1/3. There we go. Sorry, I was confusing myself trying to say the cube root of that when I needed it all in the same form. There we go. So what I did, okay, was I had to rewrite 125 as 5 cubed, but I got to keep that x up there. I rewrote 1/5 as 5 to the negative 1, set 3x equal to negative 1, and then solved for x. All right, moving on. Let's see, 25 is next. So 25 is log base 8 of 3xy, and it says to expand the expression, okay, meaning we're separating it out into pieces. So, let me see, this is kind of blurry. Gotta focus it back in here for a second. It has to have something that's, there we go. It's got to have something that's got printed lines on it, so I just grabbed that page. So, okay, hopefully that's back focused so you guys can see good. Alright, so I need to expand this. So, log of a product is equal to the sum of the logs. This is all products happening here. So, it's going to be sum of all of them. So, log base 8 of 3 plus log base 8 of x plus log base 8 of y is the answer for this one. All right, 26, ln of 10x cubed y. So here I have two things that I'm dealing with. I have the log of the product is equal to the sum of the logs, so I have 3 products here. And then within that, I also have the power rule, okay, meaning I got to pull this power out front. So I'm going to take care of the log of the product first, and then we'll go into that. So this is going to be ln of 10 plus the ln of, for the moment, x cubed plus the ln of y. Now I got to use the power rule to pull this out front. So I get ln of 10 plus 3 ln of x plus ln of y. And that there is my answer. (27) log of 8 over y to the 4th. So here I have two things I'm dealing with. I'm dealing with log of a quotient is equal to the difference of logs, and I'm dealing with the power rule. So I'm going to deal with the difference part first. So I have the log of a quotient, so it's the top minus the bottom. So log of 8 minus log of y to the 4th. Rewrite this here with the power rule. I got to throw it out front. So log base 8 minus 4, or sorry, not log base 8, that's log of 8. Sorry about that. Log of y, so minus 4 log y. Now, 28, last one of this type. We have the ln of 3y over x to the 5th. So here, I'm dealing with multiple things happening. Okay, I have the log of the product on top, I have a log of a quotient, and I have a power rule. So the very first thing I'm going to do is I'm going to go ahead and take care of this quotient, okay, to get that, so that way I don't lose any of these signs in here or anything. So, difference of logs, top minus bottom, so ln of 3y minus the ln of x to the fifth. Now I'm going to deal with my log of the product. Okay, so I'm going to separate these by adding. So ln of 3 plus the ln of y. Now, minus, I need to throw this power out front, so I'm going to go ahead and do this all in one step. So minus 5 ln of x. Okay, if you can do all this in one step and not miss stuff, that's fine. But know that if you show me step by step, I can at least see where you went wrong to give you some more partial credit possibly than if you just went straight to here and, say, mixed up a sign or something. Because that's kind of what it looked like some people did in their homework, was just mixing up a sign somewhere. All right, so these ones were to expand. But now we need to do some where we condense things down smaller. So, go up here. So we're doing the reverse now. So number 29, 3 log base 7 of 4 plus log base 7 of 6. Alright, I recommend you do this step by step, okay, so you don't lose stuff or get confused. So I would throw this power back up here, so log base 7 of 4 cubed plus log base 7 of 6. Now, because of issues that I saw happening in your homework, I would recommend, so that you don't forget to do it, that you go ahead and do this 4 cubed. That's 64. So I would rewrite this as log base 7 of 64 plus log base 7 of 6. Because now I have the sum of logs, meaning I'm going to take the product. So I'm going to end up with a log base 7 of 64 times 6. And 64 times 6 is 384. So my answer is log base 7 of 384. Okay, there's like maybe 3 people in the whole class that actually got this correct. Okay, so please make sure you pay attention to stuff and know that when you're condensing, you want things down as small as possible. I got like 4 cubed times 6 in here and all kinds of things. We want it written as small as possible. Okay. Let's see, 30. We have the ln of 12 minus 2 ln of x. So, I have a difference of logs, meaning I have the quotient, but I also have this power rule. So I would recommend doing this power rule first. So I would do the ln of 12 minus ln of x squared. Now I can use the quotient rule to give me, remember, it's always top minus bottom, so this is the top here, so ln of 12 over x squared. All right, 31, 2 ln of 3 plus 5 ln of 2 minus ln of 8. So this is another one I kind of got answers all over the board, but the answer is actually really simple. So my first recommendation here would be to throw these powers back on top. So I get the ln of 3 squared plus the ln of 2 to the 5th minus the ln of 8. Now, I would go ahead and rewrite this. 3 squared is 9, so ln of 9 plus 2 to the 5th is, let's see, 32. Yeah, 32. So ln of 32 minus the ln of 8. And now I would go ahead and do this product first. Okay, we're kind of Basically, we're taking problems and we're doing them in the reverse order. So here, okay, in 28, I did the quotient first, okay, and then I did the product and I pulled the power out. Here, I did the powers first, then I did the sums or the products, and now I'm going to deal with the quotient. So first I'm going to deal with the product. So this is going to be the ln of 9 times 32 minus the ln of 8. And now I'm going to rewrite this as the ln of 9 times 32 over 8. Okay. Now, you could use your calculator here, but I know 8 goes into 32 4 times. 4 times 9 is 36, so ln of 36 is the answer. And then, we only have a couple problems left, so bear with me. Alright, so these ones are actually solving the equations. Okay, and remember we're checking for extraneous solutions, meaning we're just simply plugging the number back in and making sure that it is true. So with 32, I have 5 to the x is equal to 32. Well, 5 raised to what's equal to 32? I don't know right off the top of my head, but I can rewrite this by, I'm going from exponential to log to solve it, so making my L, so that comes down log base 5 of 32 is equal to x. So now I can type this into my calculator. Sorry guys, my book keeps falling off and I don't know why. Today of all days it's decided to fall off a lot. Okay, so remember log base, we go to math, up arrow to log base. 5 of 32 comes out to be 2.15 approximately, okay, is equal to x, which is my answer, but I still need to check it. So what I'm going to do is, because this is a decimal answer, okay, I'm going to write this as 5 raised to the 2.15 ... is equal to 32. Okay, and then on my calculator here, what I'm going to do, and you're welcome to do it this way as well, 5 raised to, hit second, and then this little negative sign here has answer above it. That'll use this answer that was last given. Okay, hit enter. It's equal to 32. So it's good. It's actually the answer. Okay, not extraneous. Alright, let's see, 33 is next. Okay, and I know 34 was one that was really complicated, so we'll spend a couple minutes with that one as well. But 33, log base 3 of 2x minus 5 is equal to 2. Alright, so here we have a log, and to solve it, we're going to have to use the exponential. So, making an e, 3 raised to the 2 is equal to 2x minus 5. So now 3 squared is 9 is equal to 2x minus 5. Let's see, add 5, it's 14 is equal to 2x. So x is equal to 7. But I got to check it. So, log base 3 of 2 times 7 minus 5 should be equal to 2. So this is going to be log base 3 of 14 minus 5 is 9. So, now obviously I could just say 3 squared is equal to 9, but in case you want to use your calculator, which is fine, log base 3, or in case you doubt that this is correct, is equal to 2, so 2 is equal to 2, so we're good. So the answer is 7. And lastly, 34. Now 34 kind of combines a lot of stuff, so I understand why this one was a little harder. Okay, and you probably would not get one this hard on your quiz, but I do think it is good to make sure we understand it. So, I have 2 logs here. Okay, they're natural logs. I have 2 logs, and I need to solve for x. So, I know that based on my rules of logarithms, the log of a product is equal to the sum of the logs, and that the reverse is true. So, I have the sum of 2 logs, meaning I could write it as the log of a product. So, I can write ln of x times x plus 2 is equal to 3. So, this is the ln of x squared plus 2x is equal to 3. Now, this is log base e, so when I make my e here, I know that this is going to have basically an e here, so e to the 3 is equal to this. So e to the 3 is equal to x squared plus 2x. And then we would solve this. E cubed is 20.08. Let's subtract this over first. So let's do this. 0 is equal to x squared plus 2x minus e cubed. And trying to think of how I want to actually do this one. If we left it where it was, we could do this problem by completing the square, which might actually be easier. Or you could just do this by using the quadratic formula, but obviously because it has an e in it, it's kind of weird. Let's just go with the quadratic formula, I guess, and see what happens here. So, -2 plus or minus the square root of 2 squared is 4, minus 4 times a, which is 1, so 4 times a times negative e cubed, all over 2. So typing this into my calculator, let's see. So negative e cubed times negative 4 is positive 80, so plus 4. So this is -2 plus or minus the square root of 84. We're just going to call, well, 84.34, blah, 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 all divided by 2. The square root of that is around 9 point, here, let me try to put, well, trying to get this so you guys can kind of see what I'm doing here. Okay, 9.18. Basically, we can do -2. That's using the positive one, so that's 7.18 divided by 2, 3.59. And then the other option would be -9.183798. Okay, close enough. -2 divided by 2 is -5.59. Now, if you remember, I told you that negative values can't go in a logarithm. We can go ahead and get rid of this one, and our answer is just this 3.59. Okay. So, like I said, this one's a lot harder. This isn't something I would expect you to do on the quiz. Obviously, you guys saw I needed to think about it a little bit. But it's good to have a challenge problem every once in a while and just to see what we would have to do in that situation. and some reasons behind it. But I would say stuff more like 32 and 33 is what you could expect out of that type on the quiz. So remember, if you have any more questions about anything, tomorrow by 1 o'clock is the best way to guarantee that you get those questions answered. I'm usually over at school till around 2 to 3-ish, so that's why I say if I get them in at 1, I can answer the questions before I head out for the day. And you guys can obviously send me messages and stuff, and I might be able to answer that if it's just like something real quick, if it's not something, you know, bigger like this. And I am going to try to grade your other homework problems as well, so we can make sure that we're all on the same page there. But hopefully this helps you guys. Get ready for the quiz. That is now on Thursday. So have a great day.